Hello class, this is David, your instructor for Business Management 7250, Data Management for Analytics Professionals. This is lecture 12, part 2, focusing on segmentation, decision tree, and clustering using PHYTON. And this particular demonstration is slated for Friday, November 2020. And it is gonna be coming out one day earlier, simply because you will have likely a need for really using this tool for projects. So as usual, I will be presenting the information using PowerPoint and also the Jupyter Notebook. I have written the script. In this particular demonstration, we'll focus on decision tree using the iris data, and then we'll also be using clustering, the k-mean clustering technique using the ICPS data. In this particular case, a reference is shown in here, and please use this reference. The exhaustively detailed account is included. I am just bringing the information that I got from the reference for demonstration purpose. So let's just get started. So first, let's just import the necessary libraries and go to Jupyter Notebook. We got them in. Then we'll go to the PowerPoint. At the same time, also get some of the scripts required for the setup of this analysis, and this includes the figures and so on. And once we have them in, we'll be able to really just like use the subsequent steps. Requires the formation of the decision trees, the inverter tree, the one that we have already discussed in the first portion. Then the next step would be to have the file, the data that we are going to use, which is the iris data. We don't have to bring it from our directory. It's already in the library here. Just simply use the load function and it will be in here. And that actually comes very handy. Oh, there's some error. I'm not supposed to really just like head, because it doesn't have its head column. So look here carefully. The way how the data is set up is an array delimited by comma. And it has to do the way how the code is written. And actually I tried to create this one and have time to have it done this way. Otherwise I would have used the ICPS data for this demonstration purpose. But anyway, in this particular case, the sepal, as you recall, that flower, sepal and petal, the flower parts, lengths and widths are retained here. And the name of the species is not included in here, and yet it is already embedded inside, as we see later on. So the intent is to work on this 150 observations, and have on the three species. Each species has got 50 observations, as you recall. And once we got the iris data here, let's just like do subsequent steps that are very straightforward. I think they're not really quite a lot. And so there are there's the next 4 pages are, you can run it separate, but you don't really get the desired result. And sometimes you need to run the whole thing as a whole. So far what we have been doing is get code separately, which is suitable for demonstration purpose. But in this particular case, I'm going to run this code as a whole and see what we get out of it. So what this particular code does is it set up the data to be suitable for graphing purposes around here, and at the same time also it do a prediction, this prediction using the 4 columns, and the target is the list of species here. Then it will do a bunch of steps where the criteria is set up to really divide split the nodes that are identified by the model, and eventually it would also do a prediction as well in here, and quite lots of like manipulation to really make it a beautiful color, and also labeling and all that. So in the reference material we will see the output for the 3 species here, but here it's just like for some reason only one is shown. So what this one shows is the relationship between the selected variables, the sepal lengths and widths, and shows for one for the different species, and then it picks different pair of variables and show how things are related, and it shows it in different spectrum, and it shows you actually clearly distinguished or identified where they really belong. And this is really a criteria used for classifying this particular 3 species into different groups, which of course they are different species. And then once we got this one here, the one I would like really focus is how you are creating the table, the trees. And for this, let's just go to our PowerPoint and get this particular script, which is telling us, okay, I need this particular data, all the prediction, the stuff is done, the setup is already put in place, and using this decision tree classifier, the library that we have imported, and asking it to create this particular decision tree, right? So what it does is you have got the parent node and you have got the decision nodes coming up at different juncture, and it uses the Gini coefficient, which means that if a particular variable within that one has got the lowest Gini compared to the others, it will be selected as a splitting criteria. And also, if the discrepancy of the Gini, the entropy, is really high between the different nodes, between the parent and the child node, that would be just like an indication that more information is gained by splitting them. And using that one, it is really just like creating all these. So the ones that you see in here are called labels: label 1, label 2, label 3, label 4, label 5. I think this one has got like 5 labels, which is really quite a lot. Remember, we are only using 4 variables. Sometimes you can have as much as 10, 20, even just like more than that. When you have that, this thing can really just get bigger, can split quite a lot, and this is not really that big, but still it's quite a lot, very hard. And what it does is it will just like pick one of the characteristic sepal, okay, based on the sepal unit metrics, and if it is less than 1.75, put it on the left side, and if it is otherwise, put it on the right side. And then all of these guys that are ending up in here, that are actually, there are 54 of them, then the algorithm will select, look at the Gini coefficient, information gain, and all that, and it says if the value is less than or equal to 4.95, then put these guys on the left, and then otherwise put them to the right. And then it will continue doing this one here up until the point where information gain is not going to happen further. And then the question is, okay, how can we prune? How can we really just like be able to really use this one here into just manageable nodes or segments? And then we can look at the next one. We can go to our PowerPoint and get. So this is a Gini coefficient, right? When you have got like zero, around zero, all records belong to the same class, homogeneous, not homogeneous. One dominant variable can be used split. The one on the right side is homogeneous actually. This one is supposed to be heterogeneous, very heterogeneous. One guy is dominating. When the value is around zero or a little bit zero on this spectrum, that particular variable among the others will be selected as a splitting criteria. Whereas if the value is really high, and that means there is not really point to go further, that's where we stop. Then we go in here. Finally, we can really prune this one here by specifying the labels, and the way how to do that one here there is by putting one particular value in there. We say that there's the maximum depths. We set it up to be 3 at the top around here, and when we are running this one, this is what we get. The depth is all 3. It is pruned, and these 4 ones are reasonably good to really just like understand, communicate with, and so on. So decision tree is like this one here, and typically you have software to do this for you. However, if you are ready to go this route, there are like all different kinds of options, and the approach and the step-by-step process are pretty much the same. They focus on Gini and information gain, and there is a process of growing the tree and at the same time also pruning to make sure that you get a reasonably good smaller number of nodes. The last one are the final nodes, the leaf, and these are the ones that we are going to really act upon. So if you sum up this guy, this guy, this guy, and this guy, we also have one in here, the guy on this one, they should really all amount to become 150, because initially we set up them to be just like kind of the same 150. But when you go through this one here, based on the length and the width of sepal, we end up in putting them into 5 segments. So basically now we have 1, 2, 3, 4, 5 segments after pruning. So this is all about decision tree, and let's just proceed to the clustering technique. Let's go to our PowerPoint, and in the PowerPoint, this one is a little bit longer, but I'll definitely make sure that it is really just. So for this, I use the decision tree iris data for the sorry, where are we now? I went up. We should go in here. Okay, it's downstairs here. Okay, page I think it's 12. All right, we use the clustering the ICPS data in this particular case. We'll be going through this process. We import our data and so on, but at the end, it's just like using one of several dozens, if not dozens, hundreds of different clustering techniques, and this is the most popular. So for this, let's just bring the libraries that we need to have. Now we are going to be using our ICPS data. Go to the Jupyter node and got this particular libraries that we need, and this include NumPy, Pandas, Matplotlib, Seaborn, of course, the ones that will have so much. We'll go to PowerPoint, and from our PowerPoint, we'll get into getting the data that we need, the ICPS data. This is the one that you are very, very familiar with. And what we do here is just simply bring it the way how we are accustomed to bring it. And then we have that ICPS data in we also created additional variable, which is the revenue. And then we can go back to our PowerPoint and do a bunch of things using that one. First, let's just do characterize, understand this data. We know this data, but as a matter of common practice, it will always be nice to really do this very quick and dirty way. And like this one, we got this information, and what we did in this one, as you know, was we subset the number of columns that you're going to be working on. So right now we have the one that we are interested: gender, age, income. Let me go to the power so that you'll be able to see gender, age, income, and family size and revenue. There's, I think, 5 of them. So it should be very easy and handy to work on this, guys. Let's just do that thing that we know very well. What happened? I see. Oh, okay. I need to copy that one, and yeah, since it's ICP-S1, so once we have the ICP-S1, we can really run into getting this particular data script and run it on the selected data that we have. So we got this information in, and this will really definitely tell us what the relationship among different variables look like. As you can see in here, some of them are like family size has got strong relationship with age. As you can see, income also related with family size. Of course, income has got strong relation with age, and so on. This is just like a quick way of really understanding our data. Then we can proceed again to have other the things that we can really just understand, help us understand this data, right? We can also do something what you call this a correlation thing that we have already done, and even if it is not really just like regression or of that sort, we can also just simply use that one to check how things are related. It's basically what we have already seen upstairs, how things are related with each other. And we can go again and get all these calls that are helping us to really just like characterize the data, right? In this particular case, I like to do this one here as quick as possible so that I will have, because the information is already there. This is just like the one that tell us the distribution of age, and it really comes very handy to really understand it. It's not really quite common kind of graph that we see, and all of the stuff, the information that you see in here are already just like shown in there, and a matter of copying and pasting and running it. And the setup, this is just like a box plot, shows you the distribution where the median is located and stuff. And this comes really handy to see, okay, how these guys are related with each other. And later on, when they are selected as a splitting criteria, you'd have really a good sense understanding of who is doing what kind of stuff. If we have the understanding of this one here in a very clear way, then we'll be really able to be very articulate, and at the same time also make a decision that is critical and this is the same kinds of stuff about family size. You look at the box plot distribution, and you are really in a good shape. So we can go to our PowerPoint again. In this particular case, we can also do a bunch of stuff. Of course, lots of information we have already generated in using the seaborn, but the seaborn is just the one is just simple relationship. But sometimes you like to see, okay, how within a gender, how are things differentiate within each other, right? And you can also just go into the other guys and do much more slicing and dicing of the data. This actually comes very handy if you are interested to do some presentation and all that. It's not just only the clustering, but also the understanding of the data goes in hand. This is a case where you have got number of customers and their distribution by age is shown in here. I put them into different one. As you can see, those between 25 to 35 account for the bigger portion of the population, and they are the kind of customers that have got more purchasing, but it doesn't really show any kind of relationship between number and spend, but that's also possible to create it there. So let's just go to the PowerPoint and see additional features that we can really just like create. And like for instance, if we are interested to look how revenue vary by revenue, or this like the sale is varying by like age groups, customer count, customer counters, you can really just put it in here. And this is just like the spend class. We call them spend class, how much they spend, or that's the revenue actually. We can call that one as the spend class. And as you can see, it's just like 13 to 19 is the larger expenditure, where most customers spend that kind of amount. So anyway, you can continue different kinds of combinations, and you will be able to really just understand the data. Even before you go to clustering, you need to really just like understand what the data is look like. So that's what this one is doing. Now next we can go to our clustering thing. We can come in here. First, the question is, how many clusters should we have? 1, 2, 3, 4, 5. So for that, we can really just run this particular code, and all what this one tell us is the graphing, very visual display of the relationship. Let me just show you the relationship between information gain and number of clusters. And so it computes the sum of square against the number of clusters to figure out the optimal number of clusters. So that's what it does, and this can be used as a criteria to really select your clusters. As you can see in here, this is the number of clusters, and this is the one, the variability, and I think somewhere around here you will find the optimal number. And you say maybe 4, maybe you can really just go even just 5 clusters is what you really need. After this, you don't really just gain any kind of information. You don't really capture the variability. Everything's kind of uniform. So you say for this one, okay, let me have like 5 clusters. And then once you decide there, all you have to do is just get this particular so in this particular case, you are interested to look at income, to look at age, and I think instead of 2-dimensional, you can create a 3-dimensional kind of a view of the clusters, and that's the beauty of Python, which is really very empowering in so many ways. in this particular case, we say, okay, age is important, income is important, and spend is always just like a function of these two variables. And you like to see how the customers are clustered into that group, right? And then you run this one here, you'll get this three-dimensional where the number of customers are really put in different groups, like by the age in here. As you can see, the total number of spend, this is the total spend dollar, and this is the age, and this is just like the income label. As you can see, like more customers in the bigger age group tend to like have more spend, and the red column shows you the lower income. The higher income ones are just very few, but their spend is also reasonably good. But anyway, you can't really just have these kinds of approach to see, okay, what is the distribution of these different customers in three-dimensional space, instead of having, okay, here's cluster 1, here's cluster 2, and then this customer belongs to this one here. So this is just like a way that you can slice and dice the data that you have. And if you are also interested, you can also create different combinations of to create this three-dimensional variable. In this particular case, we are focusing family size, income, and spend. So instead of like age here, we are putting like family size, how that's gonna be impacting it. And you can go to the and run this one here. Again, you'll see the distribution of your customers across these three dimensions, and you'll be much more powerful, much more, and you can really just like tweak the graphs according to the color that you need, and in terms of like the labels and stuff. And at the end, you are able to really just like tell a better way of understanding these customers than what you can really get for two-dimensional clustering, or just by using different other approaches. So this is another form of like grouping customers into similar homogeneous groups, and you can have various combinations depending upon your test. And I hope you can use this kind of approach for your analysis and understanding. Since we don't have really time, I didn't really just go through the course and stuff. They are self-explanatory. Run it, and if you got stuck, please let me know. And I hope you enjoy our demonstration, and we'll definitely see you next time around, and have a nice day. Take care now.